For today's video, we're going to solve the integrating factor found by inspections. We have d of xy is equals to x dy plus y dx. We simply use the product rule of derivatives. And we have d of x all over y is equals to y dx minus x dy all over y squared. We use the quotient rule. We have d of y all over x is equals to x dy minus y dx all over x squared. We simply use the quotient rule also. We have d of x squared plus y squared is equals to 2x dx plus 2y dy. We just simply as derive it. And now let us proceed to the given problem. We have y times x cubed e raised to the x and y minus y dx plus x times y plus x raised to 3 e raised to the x and y dy is equals to 0. And now, before we start to get the integrating factor, let us have the simplification of the equation. We have, let us distribute the value of y and value of x. And now we have x cubed times e raised to the x and y times y minus y squared dx plus x y plus x raised to 4 times e raised to the x and y dy is equals to 0. And now let us also distribute the dx and dy. And now we have x cubed times e raised to the x and y dx minus y squared dx plus x and y dy plus x raised to 4 times e raised to the x and y dy is equals to 0. And now let us arrange all the integrable combination. We have x raised to 3 times e raised to the x and y times y dx, and this one plus x raised to 4 times e raised to the x and y dy, and this also we have minus y squared dx plus x y dy is equals to 0. And now let us factor it in order for us to get the integrable combination. So let us have x cubed times e raised to the x and y. We have y dx plus x dy. And now let us factor it also. So we have plus y times negative y dx and plus x dy is equals to 0. And now let us rearrange it. So we have x raised to 3 times e raised to the x and y times y dx plus x dy plus y times x dy minus y dx is equals to 0. In order for us to remove this x cubed and to have y all over x, is let us have multiply both sides by 1 over x cubed. So we have cancel it, so we have e raised to the x and y times y dx plus x dy, and now we have plus 1 y all over x times x dy minus y dx all over x squared is equals to 0. And now let us use this integrable combination. As we notice that this part is equal to this d of x and y, and this part is equal to the d of y all over x. So let us rewrite it. So we have e raised to the x and y times d of x and y plus y all over x times d of y all over x. And now let us proceed to the integration. So we have the integral of e raised to the x and y times d of x and y plus the integral of y all over x times d of y all over x. The integral of e raised to the x and y is simply as e raised to the x and y plus the integral of y all over x is y all over x raised to 2 all over 2 is equals to the integral of 0 is c all over 2. And now let us multiply both sides by 2. So let us multiply 2 times e raised to the x and y is 2 e raised to the x and y plus multiply this one, so we have cancellation. So we have y all over x raised to 2 is equals to, we have cancellation, so c. And now let us have 2 e raised to the x and y plus, let us simplify it. So we have y squared all over x squared is equals to c. And now let us multiply both sides by x squared. So we have x squared times 2 e raised to the x and y. So we have 2 x squared e raised to the x and y. And now we have cancellation. So we have plus y squared is equals to c x squared. So this is the final answer.